Welcome back to Steve Robb Reviews. Today's review, well, I think you're going to find it very fascinating if you do any sort of electrical diagnostics. And if you don't do electrical diagnostics, I bet you're going to find this fascinating as well. So we're going to first start off with, well, many years ago I built two diesel engines up. For you that follow the channel, you know I got one that's just sitting there in a crate on the side of my garage. And the other one I built into a diesel log splitter. It's up in my cabin up in Northern Ontario. And I'm going to show you some pictures here, some still shots, and then a small little video I made a long time ago, and of the log splitter just starting up. Now, at this point, it was not a log splitter, it was just a standing engine. So, the main part about this video is going to be all about how to do an electrical diagnostic on when you have a situation where you turn the ignition switch off. Doesn't matter what kind of piece of machinery it is, if it's a DC 12 volt circuit or any voltage as long as it's DC. This is what this is pertaining to on this particular video. But you got something on. That's after you've turned the circuit off. Turn the key off like I did on my log splitter, and there's something that's drawing power. And it's not so easy to figure out. These parasitic draws, well, they can be challenging. There's multi-ways on how to find out which circuit is on, which circuit is off, which circuit is supposed to be on, which circuit is not supposed to be on. But I'm going to show you a little tip here today that might save you a lot of time. So take a look at the video first, and then we'll come back and you'll see the challenge I have in trying to figure this out with the wiring job I did on this log splitter. Okay, I'm going to turn you around. I got the panel off the side here, and I'm going to show you what it looks like inside the control panel there. This is the control panel here. I got a flashlight in behind, and you could see all the wires in here. You'd never know there's this much to go to making a harness up, but yeah, I mean, I got relays in there, you know, running off a negative, running off a positive, triggered off of, either one. And I've got a delay timer, this one right there, for the stop solenoid. Yeah, there's a lot to it. You take your time, and anybody can do this. I'm telling you what. Now, the only thing I've done, a friend of mine is a master electrician, and he said, Steve, doesn't like the idea of me putting all them grounds into the wood, because he swears that wood can be conductive. And but he said, you know what, for your system, no problem. Because, but I mean, can you imagine one wire at a time doing all this? Okay, so as you can see, that's a little bit of a challenge there. I got so many circuits in there, it's very difficult to figure out what is on. But in my particular situation, I've got the same fuse block as I'm going to show you right here. And I'll show you a good tip on how to figure out which one of these fuses is actually, well, on when it shouldn't be. Now, many times you're thinking, okay, well, just start pulling fuses, right? Well, it's not so easy as that. And for you that are in the automotive trade, well, yeah, it can be difficult when you pull fuses out, put them back in, you're having things go on, things go off. So, I mean, this is a really fast tip on just when all the circuits are supposed to be off. You want to see which one's on? Let's go over to the bench. Let's take a look. Okay, let's go over to the bench here and let's just take a look what I got set up here. So I got a small little array of LED lights here running off of 12 volts. I got the feed coming in. You got the positive, you got the negative. They're going through my meter in series. Turn that on. It's going to show the milliamp draw or amp draw. And this one here is going to be set to millivolts. And all we got here is the same fuse block that I have in my log splitter. And we're going to energize the circuit. I'm going to go over here and turn it on. So let's do that. And there we go there. Just let that stabilize a bit, and it's just around 12 volts, right? We come over here, you can see that the light is on, right? So let's just turn the meter on and see how many milliamps this is drawing. So this is 960 milliamps DC, and we're going to turn this one on. We're going to turn this one on to millivolts. You can see it right there in the screen. Millivolts DC. Everything is DC. You got the light on. There you go. So the first thing that we're going to do is we're going to turn the power off. So as you can see, there's no power going through here, right? Keep this meter on, and it's on millivolts DC. Let's do some testing. We just got a regular fuse here going through the circuit, and let's do some testing. Okay, so you can see everything there, and all we got to do is just have our meter set for millivolts DC, and you know there's a test port on the top of every fuse, and when you put it on, there's no current flow. You are going to get the 0 reading every time. This is just ghost voltage, so when you put this on, yeah. So now let's turn the circuit on. You can see that the light is lit, and put it on the top of the test parts. 1.2. Now that is just incredible that it will actually show you the reading. Now that shows that that circuit is on and it's drawing current. Now take a look at these two test leads. You got the positive, you got the negative. The multimeter on voltage does not read voltage directly. It reads the difference between the positive and the negative, makes a calculation inside, and then displays it on the display screen. So, we go back, there it is. So what it's doing really is just measuring the difference between this side of the fuse to that side of the fuse in millivolts, and this will tell you if there's current draw or amperage going through the circuit. You could have voltage going through the circuit but not have any amperage movement, and it won't display anything. So what I'll do over here is I'll just disconnect the light. I'll disconnect the light from this end. Okay, so I disconnected the light, and the circuit's exactly the same, and you're going to get 0 again, just like as if I turn the power off at the power supply. And that will tell you exactly which fuse, if you have a whole bunch of fuses here, which one actually has a load on it. Not voltage, but a load. So if I change, we just go over to say voltage. We got voltage DC, right? And the circuit is energized, but there's no load on. So if I just go from the top of the fuse to the negative, there's your voltage, right? Now that doesn't tell you there's any current flow because that light's not on, right? That just tells you the system voltage. So by going at the top of the fuse on either side and doing a voltage drop between one side to the next is telling you if there's current flowing through that fuse. So next year I'm going to use that particular method to find out which of them fuses has current flowing, and I'll be able to backtrack and see exactly why I have a draw on the circuit when I have the ignition switch off. And I find a little tip like this could save you hours and hours and hours of looking around trying to find out where you have a parasitic draw. There's many other ways to do this, you know, with different techniques, but this is one that you got to put in your toolbox. And remember, the next time that you run into one of these situations, well, you can think about this tip. So thanks for joining me here today. Come back again. If you haven't seen this channel before, you're welcome to subscribe and see some interesting things that I do every week just like this. Cheers.